Hello, I am David Mammolenti. I am the Executive Vice President at Belvac Production Machinery. Behind me are the 49 flags that represent the different countries where Belvac has equipment operating and the manufacturing of containers around the globe. Today we're going to take a video tour of our manufacturing facility in Lynchburg, Virginia at our corporate headquarters. The Necker assembly line is configured as a mixed model line. This allows for the flexibility of producing the 595 product or the Belvac Necker equipment. The line is designed around having the right components at the right place with the right tools to improve the overall efficiency and quality of our assembly processes. All of our work instructions are very detailed, which allows us to document the assembly techniques and also to document our quality inspection criteria as we go through the entire build process. Once the Necker module is complete on the assembly line, it's brought over to what we call our final assembly area. The modules are then joined together, all the electrical components are brought together, and all the finished assembly is completed. Once the machine has been complete, we will go through a rigorous break-in period on the machine to validate that the machine does meet the specifications required by engineering. The conveyance system above will allow us to then transfer cans into the machine at rated speed and validate that the customer's cans are being made according to the specifications. It also allows us to validate the inspection systems in our vision systems internally. As part of that, we go through what we have an internal buy-off, where we do make sure that all of our quality checks are complete as part of the process. Once the machine is complete and goes through all the quality checks in the buy-off process, the machine will then be broke down, palletized, and shipped out from our facility. As we continue our tour, we are stopping in front of the RAM manufacturing cell. The RAM manufacturing cell utilizes, all the lean techniques to create the cell. It's designed in a U-shaped configuration, driving single-piece flow. The cell will only operate based on customer demand. So if there's no customer demand, the cell will not run. So everything is driven through a pull system. We start out in the RAM cell with raw material. The raw material comes in as a bar. The bar is actually on the carts as it starts through the initial operation. The raw material is actually on a pull system also. The material is actually triggered as it's used in the machine, the cart gets empty, and what will happen is it will then get replenished from another cart, and then we actually have an email trigger that brings to our supplier to actually trigger him to bring in more material. The cell actually will go through 4 different operations using a single piece flow. At the end of the process, it'll come out as a complete finished RAM assembly. The RAM assembly then is ready to go to a customer or actually go to our final assembly operations. Each of our main cells are driven by 5 key metrics. The first one being safety. We focus on quality, inventory, what we call cycle time, customer service, on-time performance, and productivity. Every day, the operators will track their performance, look for opportunities in terms of how they can improve the overall cell operation to make it more efficient and actually to help drive out costs as part of that. Then based on this, we have a board that we have the employees actually generate different ideas in terms of what they can do to help improve the overall efficiency of that. The operators get together, they prioritize in terms of what are the key initiatives that they want to implement to help improve the overall performance of the cell. And then we give them time as they go periodically throughout the week that they can get together, they can work on these continuous improvement actions. So at the end result is they can actually see the trend going in a positive direction and increasing the overall performance of their work area. Belvac continues to invest in its core competencies to drive the right product, the right cost, and lead times for our customers. This particular machine is a state-of-the-art 5-axis precision machining center that will produce tight tolerance components like star wheels and ram blocks. These components as star wheels here are a very key part of our necking process. They are responsible for transferring the cans at high speeds up to 3,600 per minute. We have to ensure that the cans are not damaged as part of that transferring process. The machining center will bring in raw material and actually machine it and have a completed component that will exit the machine as shown here next to me. The pallet pool system allows us to set the machine up external to the machining cycle, which allows us to run in a single piece flow into the machine, which allows us to have the flexibility to meet the customer demand as required and meet the lead times needed in the marketplace. Another key competency at Belvac is our shaft manufacturing. This is one of the latest investments Belvac has made to improve the overall quality and lead time of our product. In this particular example, Belvac has been able to reduce the operations from 7 down to 2. The reason why the shaft is a key competency to Belvac is it's really the foundation, the building block of our product. In assembly, everything is then assembled to the shaft and creates the working turret as part of our necking process. Our quality assurance department plays a very key and critical role in terms of the overall quality of our product that we produce. Our machines run up to 3,600 cans per minute. We have to ensure that our machines are not going to scratch, dent, or damage the printed containers as they enter our machine as they go through the forming operations. So as part of that, this operation here is actually designed to ensure that the precision components are manufactured correctly and that they actually meet those specifications. In some cases, we're utilizing touch probe technology where we'll actually touch the component and it'll record the actual dimensions. Or in other cases, we're using fully automated systems like the one behind me. We take the engineering specifications and 3D model that they've created. We generate programs that will actually be used in the equipment to measure the part. As part of that measuring, we measure the profile tolerances of the components, we measure the hole accuracies, the size of the components, and we measure in many cases down to the micron level to ensure that the quality of the product is there. The warehouse is configured in an efficient flow from the receiving dock through storage, through our picking operations, through shipment. Belvac carries thousands of parts to support our products in the field, which allows for quick delivery anywhere in the world. The vertical storage units improves our overall picking efficiency because we're able to store small and mid-sized components. These components are brought down to the operator and allows us to improve the overall efficiency and accuracy of the orders that we ship. Once the order is picked, the order is then transitioned over to our shipping department where the order will be re-verified, packaged, and shipped to the end customer. In our engineering department, every part is designed in 3D, using analytical tools to ensure proper performance and life. Each part is then combined in models to facilitate tolerancing of components for proper form, fit, and function at assembly. We hope you have found the tour informative today, and we appreciate you taking the time to watch the video.